Okay, now I just want us to take a look at a kite and a rhombus. And just want to look at the formulas for finding the area of a kite and the rhombus. Now they both actually share the same formula, which is a half xy. Okay, and then that's where the x and the y, like in the kite, the x and the y are the diagonals. So it's the length of the two diagonals. And in the rhombus, the same. It is the length of the diagonal. So that's x and that's y. Each of them sharing different diagonal lengths. The rhombus, additionally, for the rhombus, because the rhombus is a parallelogram with all four sides equal, then if you've given the base and the height, you can also find the rhombus by doing area is base times height, just like a parallelogram, because it's the same as a parallelogram with equal sides. Now, I just want to go through how you actually find this area formula. So I'd like you to get a piece of paper, like an A4 piece of paper, and what we're going to do is we're going to construct a kite. Now, in order to construct your kite, you need to draw a line somewhere sitting in the middle of your piece of paper. It can be of any length. And then what I want you to do is I want you to draw another line, and what we're constructing here is the diagonals. But I want you to make sure your line is perpendicular to the line that you have just drawn, and that these two sides will be exactly equal. So that means that it's bisecting or cutting in half that line. Then if you join up all the points, what you have there will be a kite. And that side will equal that side, this one will equal this one. Diagonals meet at 90. Okay, so when we're looking at this here, we have, I'd like you to cut out your kite. Okay, and I would then like you to cut it so that, I'll just tell you where to cut it actually, along this line here. I want you to cut out your kite so you have two triangles, one like that and one like that. But before you actually cut it out, I want you to label this one X and that one X, okay? So that means the base length of the triangle will be X. And I want you to be aware that this is Y, okay? So we're going to call that, when you cut it, it'll be a half of the Y and a half of the Y. So that's a half Y, a half Y. I want you to take your two triangles and put them on top of each other. And I want you to realize that they're actually equal in every regard. This is called congruent. So what this enables us to do is if we find the area of one of the triangles, like we just find one of the triangles, then all that we need to do is we need to double it to get the whole area of the kite. Okay, so we're going to do this in terms of the X and the Y. So the area of one of the triangles, the area of a triangle is a half times the base times the height. Now, when you do have that triangle, this is a half Y and this part here is X. So it's a half times X times a half times Y, or a half Y. So I'm going to group the numbers together because there's a times in between the half and the Y. And I'm just going to put a half times X times Y. Now a half times a half, 1 times 1 is 1, 2 times 2 is a quarter. If you think about that, if that's a half, and then you cut that into half, like you just had half of it, it would equal 1/4. So it's 1/4 times the X times the Y, or 1/4 XY. Just note that that's 1/4 XY is the same as, if you put the X over 1 and the Y over 1, it's the same as XY, because 1 times X times Y is XY. 4 times 1 is 4. XY over 4. Okay, so that's just the area of one triangle. If we want to get the whole area of the rhombus, we have to actually double our quarters and double the quarter. Now, if we double the quarter, we actually then get 1/2. So it's like 2 on 1 times a quarter. 2 times 1 is 2. 1 times 4 is 4. 4xy. 2 on 4 equals a half. So the area would equal a half xy, and that's the formula. Now, if you've got another piece of paper, go and get another piece of paper, and what I would like you to do then, I want you to draw another line, and I want you to cut it exactly in half, so that's bisected. And then I want you to do a very similar thing. Doesn't have to be, can be any length you want. Draw a line right in the middle that is bisects the other line, and it is also perpendicular. So get your ruler and just make sure your ruler is straight on edge, so it looks like a right angle. Join the sides up like this, okay, and this here will be a rhombus. To check that it's a rhombus, I want you to get your shape, and I just want you to measure the lengths all the way around the outside. When you do that, you'll find that every length should be the same if you have drawn it really nicely. Now, this here, this would be your half y. So same thing, because that's y, and this here is your x, and it's going to actually follow exactly the same pattern. So you see a rhombus is like a kite as well, except the diagonals actually bisect each other, like the second diagonal. The sides are also all equal in a rhombus as well. So let's just look at the rhombus, and let's just look at, if I was given the diagonals, right, that was going to be a side length. Let's just say I'm giving the length of the diagonals, so that's 20 centimeters, and that there, let's say that's 30 centimeters. So using the formula, it would be a half times 30 times 20. So that would be 300 centimeters squared. Okay, so the formula works because it's a half times x times y, and x and y are the diagonals, and that's what's going in there. Okay, if you just did it as two triangles, then if this is 20 here, that would be 10 there. And this here would be 30 because that's the base. So the area would be a half times 10 times 30, or a half times 30 times 10, which will be 300. A half of that is 150. Now because we've got two triangles, if we double that, the whole area will equal 300 centimeters squared, which is exactly the same result as up the top there, 300, as if we did it as two triangles. So doing it using the formula is a lot quicker, and we don't have to do it with the two triangles.